So in this video, we're going to talk about the law of cosines. Now, to generate and derive the law of cosines, we'll go ahead and we'll start with our triangle now, our oblique triangle, on the xy plane. So I'll go ahead and I'm going to try to make this look not like a right triangle. And so in doing so, I've now given myself the option of calling this alpha and A, maybe a B there, maybe a C there. Again, this is not supposed to be a right triangle, so hopefully yours doesn't look like it. But what I'll do now is I'm going to go ahead and just be a little creative here now that we've got it oriented in a coordinate system like this. I can see that this point right here is going to be the point C0. And this point, this is an arbitrary point x, y. Now, one of the jobs or one of the goals of solving a triangle is obviously to figure out what A is. So if I wanted to figure out what A is, I could just use a distance formula between the point xy and the point C0. So the distance formula says that A equals the square root of x minus c squared plus y minus 0 squared. Now, big picture, I don't want to be dependent upon x and y. That's an arbitrary point. So I'll go ahead now and drop a perpendicular. I know that this distance from here to here is x. I know that that's y. And so now I can see sine of alpha would be y over b, and cosine of alpha would be x over b. Now, solving each for x and y equals b sine alpha, x equals b cosine alpha. I'm now going to take the y value here and the x value here, and I'm going to plug them in there and there. And in doing so, you'll see how I'm no longer dependent upon x's and y's anymore. Now, I'm also going to do one more thing. I'm also going to square both sides in the process here. So by doing this, this is going to give me an a squared equals, the x is going to be a b cosine alpha, and the y is going to be a b sine alpha. So now, let's clean this up. This is going to give us a b squared cosine squared alpha minus a 2bc cosine alpha plus c squared plus b squared sine squared alpha. Okay. Now, the next thing I'm going to do is I'm actually going to set these two things next to one another. Okay, I'm going to set those two things next to one another, and I'm also going to factor out a b squared. So by doing so, that'll be a cosine squared alpha plus a sine squared alpha plus a c squared minus a 2bc cosine alpha. And I can also now see that cosine squared plus sine squared is going to be 1, leaving us with the end result of a squared equals b squared plus c squared minus 2bc cosine alpha. And that's going to be one of the forms for the law of cosines. Now, if you look carefully at my labeling in this picture up here, this was all arbitrary. You can label however you want to. I could have solved for C or for B or whatever. So there are alternate forms of this, but you should recognize the pattern. Another form would be B squared. And notice how in the original that we came up with, once you have an A, there are no more A's over here. Once you decide you're going to have an A on this side, it's always going to be the corresponding angle inside the cosine. So here, b squared equals a squared plus c squared minus 2ac cosine beta. Similarly, then c squared would be a squared plus b squared minus 2ab cosine gamma. So all three of these forms work, and it just depends on the given information as to which one of these you'll want to use. All right, so in this example, we're again solving the triangle given the information. And as always, the most important thing to understand in a problem like this is you don't have any choices. It's not like you can say, oh, I'd prefer to use the law of sines. You can't. The information that's given to you right now, it does not allow you to use the law of sines to get anywhere. So by default, we have to use the law of cosines. And for the law of cosines, I'll go ahead and write it out so that I can talk about it a little better. It doesn't matter which form you use. I'll just go ahead and say a squared equals b squared plus c squared minus 2bc cosine alpha. So if we use this form, it's pretty clear that we know a, b, and c, so we're going to be solving for alpha. So one of the things that I'd recommend doing is actually solving this formula for cosine before actually plugging numbers in. So if you take the 2bc cosine alpha over to the other side, on the right you'll have b squared plus c squared minus a squared. If we divide by 2bc, b squared plus c squared minus a squared over 2bc. So plugging all that stuff in now, I'll get cosine alpha equals a 9.8 squared plus a 6.2 squared minus a 4.1 squared, all over 2 times 9.8 times 6.2. Now, cosines are a little bit safer than sines because we all know that cosine inverse is going to be exist in 1 and 2, which is where the angles of a triangle are allowed to exist in on the unit circle. So when I go ahead and I run the law of cosines here, an inverse cosine this, I find out that my alpha is going to equal approximately 14.4 degrees. So there's our alpha. Now, to find beta, or gamma for that matter, you do have options now. You can certainly use the law of cosines, or you can use the law of sines. Again, the law of cosines is probably a little safer because of how inverse cosine is defined. The law of sines, however, is probably a little faster though. So it doesn't matter to me which way you go, just make sure you get the right answer. I will use the law of sines here just so I can make a point, okay? So if you prefer law of cosines, use law of cosines. So by the law of sines, I'll take sine of alpha, which is 14.4, over A equals sine of, let's say, beta over B, which is 9.8. Now, when we solve this, we actually find out that beta is going to equal 36.8 degrees. So you might not think that's very alarming at this point, but if I now find gamma as 180 minus alpha minus beta, that's going to give us a 128.7. Now, this is where we have to be a little careful. A moment ago, we went ahead and we inverse signed this right here to get beta. Now, inverse sine is only going to exist in quadrants 1 and 4, so that's why it gave us this angle here. But this isn't actually the angle we want. And I know that because if we look at the given information, my largest angle has to be beta since B is the longest side. And by this calculation, beta is only 36.8. So we can't move forward with the 36.8, but we understand that the angles could come in quadrant 2. So what I'm really going to need to do is ignore this right here, and instead for the beta, I'm now going to take beta to be 180 minus the 36.8, which gives us the 143.2 that it should be. So using the law of sines, you'll get the right answer eventually, but your calculator may mislead you a bit. So bottom line is law of sines might be faster, but you do need to be careful. Law of cosines, needing to use the inverse cosine function and having it defined in quadrants 1 and 2 does make it a little safer. So it doesn't matter to me which one you use though. So from here, let's see, we have A, B, C, we have alpha, we have beta. So the last thing that we need is the gamma. So I would take 180 degrees minus the found alpha minus the found beta, and that would give us a gamma of 22.2 degrees. So there are the three missing angles from the original problem.